Hi, this is Jose Luis here, and welcome to another video on this series, Introduction to Parametric Modeling. In this video, I would like to do a hands-on exercise where we're going to model a brick wall parametrically. It's going to be a very simple brick wall, and there's many different algorithms or many different ways of doing this depending on what your inputs are. For us, I just want to make like a really simple one where I want to be able to control how many bricks are in one direction, how many bricks are in the other direction, and the size, the dimensions of each one of those bricks, but also the mortar between them, right? But what's most interesting from this exercise perhaps is that we're going to also incorporate an effect here, which is going to be, we're going to model how this brick wall could look if it was under the effect of an explosion. And in order to do that, and it's going to look something like this, we're going to have some kind of notion of time, and as soon as time increases, some of the bricks are going to get pushed away much farther and are going to start spinning randomly in the world, whereas the ones that were farther away are going to not be so affected. We are going to use like different levels of randomness and different logics of attraction repulsion to achieve this effect, and we're going to end up the video creating an animation that is going to depict this explosion logic. And I'm kind of on the way. I'm going to get hit in the head by a brick. But it's going to be really cool, okay? Obviously, the explosion is not going to be physically accurate. It's just going to be a visual simulation, but it's going to be really useful to understand concepts of randomness, concepts of physics-based simulation, and all those kinds of things. So I think it's going to be fun and interesting. Perhaps it's going to be a bit more advanced than the general thread of tutorials that I've been following, but you're pretty advanced already on this series. So I think that if you're interested, I think you're probably going to be able to take it, okay? So let's talking and more doing. Let's start modeling a parametric brick wall. All right, let's get started. So there are many different ways of creating brick walls. It depends on what are your parameters, whether if you have like a surface and you want to generate like a layout of bricks that approximate that surface. That's one way to go about that. Another way is like if you have the axis lines on the floor and you want to populate bricks on top of those axis lines, that's a completely different story. Or if you, there's like many different ways of creating arrangements of bricks, also based on the pattern, based on many things. So for this one, I actually want to keep it fairly simple because I'm more interested in the explosion part than I am in the generation of the brick wall. So I actually want to propose a very simple method to generate this brick wall. For me, what's going to be important as parameters in this particular exercise are going to be how many bricks do I want in one direction, how many bricks do I want in the vertical direction, and then the dimensions of the brick. As simple as that. And then the more rows, the more columns, or the bigger the bricks, then the larger the wall will be. And I'm going to assume that it's going to be a very vertical wall that is probably going to be on the XZ plane, like vertical wall, something like that, okay? But again, this is a very simple way of looking at it. If you will need other inputs, such as a surface, whatever, there's like other algorithms. Maybe at some point we can do examples about that here in the channel. We'll see about that, all right? But I actually like this example because it's a bit more data-centric and it involves a little bit more of the data manipulation as opposed to other examples. So, and I think this is something that I want to strengthen in this series with all of you. So that's why I'm going to choose this one. Now, what is this process going to look like? Well, it's going to be very simple as we have seen before when we create arrangements of things that have slightly different orientations or slightly different locations, then it's very common or very useful to think of these walls as arrangements that have actually several subgroups of elements within them. So for example, in this case, I think it would be useful to think of the wall as having three groups. One of them is going to be what I'm going to call the base bricks, which is going to be the first layer of bricks, which is going to be all full bricks. And then that same layer every other layer as we go up in the direction. As you can see, these bricks form a perfect grid in the 2 dimensions, so it's going to be very easy to generate this sequence of bricks. The other one, and then the problem of generating these bricks will basically be reduced to generating a collection of points that I can use to draw the boxes on top of. The other layer of the other group of bricks that I want us to think of is going to be what I'm going to call the central bricks. Because bricks are staggered, because they need to overlap over each other, then we won't have a perfect 2-dimensional grid. But every second layer, we will have the bricks displaced an offset of half a brick, and then the central bricks will have a special condition. They will have one brick less than the other ones per row, and also they will be offset half a brick length. So, but they themselves can also form a 2-dimensional grid every 2 rows. So those I'm going to call the central bricks, and it's going to be a second group. And for us, we will also have to figure out how to generate a grid of points that is the base of all those bricks in order to generate the boxes that will represent them. And last but not least, we will have what I will call the edge bricks, which is, because the bricks are staggered, to have a perfectly square bound kind of brick wall, I will need to create a special subset of small half bricks that will be inserted on the sides of what is it called? On the sides of the wall. Okay. Now, also, I have not talked about that in the parameters, but very likely I will want to control also perhaps like the thickness of the mortar between bricks. That could be an interesting thing to do, because it will also make it easier for us to see them when we render them, for example. So I may want to add that as a parameter as well. As you can imagine, the problem is going to be as simple as generating 3 families of points, or better yet, 3 families of planes, on top of which we will generate these boxes with the control dimensions minus the offset of the mortar. Okay, so I think that is going to be the first step. And as we figure this out, and as we get the brick wall up, then the second step that we will follow further down in this video will be figuring out an algorithm to create the effect of an explosion in front of this brick wall. Let's get started with this one, and then we can figure out the explosion part. So I have gone ahead and I have started a Rhino file with a grasshopper definition, where I have created a bunch of sliders representing how many bricks in the X direction, how many bricks in the vertical direction, the width, height, and depth of each brick, and an extra parameter for the thickness of the mortar. All right. And then, because I like having some kind of Rhino connection so that I can move things around, etc., I've just created a dummy point in Rhino that I will use as the base for, set one point here that I will use as the base for the first brick, so that I can move this point around and move the wall around in Rhino with like this tactile interface kind of situation. And then what I'm going to do is, very simply, I'm going to create an XY plane that is based on that point. And I'm going to create a box that is going to be centered around that point. So if I'm going to go here to box, and I'm going to say box centered on a plane, then you can see that this is going to be the plane of the box. And then the size of the box in the X direction is going to be X. The size of the box in the Y direction is going to be the depth. And the size of the box in the Z direction is going to be the height. Is this so? Let me bake this, and let me now measure the distance between the starting point and the end point, and you can see that it's 1.6. That's what that's what I was afraid of, because the size of the box in the X direction is actually double the size. So this is not exactly what I want. So what I would like to do here is I would like to create an expression where I'm going to take this value, the dimension, I'm going to take the mortar, and then I'm going to say the size of the brick in one direction is going to be whatever you're giving me minus the whatever you're giving me minus the mortar width, and this is going to be divided by 2. All right, so that's going to be and that's going to be the same for each one of the 3 values. So this is going to be this one, and it's going to be this one, and that's what I'm going to use for the x, and this is what I'm going to do for z, and this is what I'm going to use for y. And where is my point? Oh, I deleted my point. Sorry. Okay, I wanted to delete this. And now let me bake this brick to see if it's okay. So I'm going to bake this brick, and now I'm going to say that the distance between this point and this point now is 1.78 millimeters. That sounds about right. Okay, and then all right, and then I'm going to make the plane a little smaller. Or maybe I should just make the bricks bigger. I don't know. I'm gonna make the plane a little smaller in this case because it's taking up a lot of real estate here. Or maybe even smaller, 0.3. Okay. All right. So I have the first brick. I think we are off to a pretty good start, right? So I have the first brick, and then what am I going to do? Well, this is the first brick for what I have called the family of base bricks, okay? So remember, because I have now this point here, and you see that in the diagram I am representing it from the bottom, but I've actually chosen to just use it from the center, so maybe it's just easier to think that these points are going to be on the center. All right, so I have the first one. Now that what I need to do is I need to just generate this first row, and once I have that row, I will be able to copy it and copy it as many times in the vertical direction. So let me create that row by making sure that I create a series of numbers. Okay, I'm going to create a series of numbers. I basically need to take this box and move it along the x direction. So I'm going to create a unit vector x, and as many times as bricks I have in the horizontal direction, and then the distance between them has to be the distance has to be this distance here, the width of the brick, including the mortar, right? So that's why I need to generate a series of x vectors that starts with 0, where the step size is going to be the width of the brick, and where the number of values is going to be how many bricks I have in the x direction. So that I'm going to compute here, and you can see that now I have the 5 bricks, and they're nicely separated by this 0.2 millimeter gap. Is that correct? Let me bake this, and let me make sure to measure the distance between them. So this one, distance 0.02. All right, wonderful. So this is working. However, of course, one thing to notice here. What I have done is I have taken these bricks, and I have taken the one brick that I generated, and I have copied the brick along the x direction. That has already created one box here that is redundant, right? But at the same time, because I'm moving the whole brick, now I have lost references to where the center of this brick is, where the center of this brick is, and where the center, which I actually will need farther down the line when I start doing the explosion part. Because I will need to calculate the distance of the bomb to each one of the bricks, and right now I don't have a reference to the brick. So, and because I also discussed in previous videos how generating complex geometry in a box may not seem complex, but it's much more complex than a plane. So how generating complex geometry and as an intermediate step, if you're not going to use it, is not a great practice. So actually, I would like to suggest that we put a hold on creating any kind of brick yet. And what we do is instead we work only with planes. And what we do is we copy these planes, we create arrays of planes, and then when we are done with creating all the planes, then we use those planes to generate clean boxes that are perfectly ready to be populated like this, you know? So that's what I'm going to suggest right now. So that's why I'm going to absolutely forget about I'm going to forget about creating boxes yet. I'm going to concentrate on creating the planes that are going to be the centers for the boxes. And then eventually we will create the boxes at the very end. So I'm going to group this here. I'm going to move this all the way here. And then, so this is going to be the first row of the base bricks. And then what I need to do now is I need to copy that row many times in the Y direction. All right, so in the vertical direction. So how many times? Well, if I have 6 rows, I need to copy it 5 times. Oh, sorry, 3 times. So that's going to be the amount of bricks in the vertical direction divided by 2. So I'm going to take this and I'm going to use an expression. I'm going to use a lot of expressions today. I am not going to do any. So I'm going to take this and I'm going to say 0.5 times the value of x. So that is what I want to do. So this is going to give me the value of 3. And then what I need to do now is I need to take all these planes and copy them in the z direction 3 times. So if I have 6 here, so half the amount of rows. So very similar as well. So I'm going to do series and I'm going to start with 0. The step size is going to be 2 times the height of the brick, because remember, in this case now, the blue rows are spaced 2 bricks apart. So I'm going to do another expression here, which is going to be, I'm going to take the height of the brick and I'm going to multiply it by 2. And I'm going to do, the step is going to be 2 times that. And then how many values do I need? It's going to be half the amount of vertical rows. And I'm going to use that to create C vectors. And then I'm going to use that to move all these planes in the Z direction. But you're seeing that we're getting data problems here. So what I'm going to do is I'm going to graph this and I'm going to use this here. And now you can see that what I have is a data tree that has 3 branches, 1 per row, and then 5 planes, 5 planes for each one of the rows. All right. And I have decided to graph here just because I think that having the bricks on the same row, on the same list, is a little cleaner than it is the other way around. But there's no big particular reason here. Now, this could fly, this could go well, except for the fact that if I now have 5, 4, 3, 2, well, this actually is working. So if I have 7 rows, this is fine. So, okay, this is going to be fine, but it will not be fine very soon. So maybe what I can do is I'm going to start organizing things a little better here. So these are going to be, and I'm going to create a plane box here, and I'm going to put the planes here, and I'm going to call this base planes, for example. Base brick planes. All right. I'm going to turn on the bucket and then I'm going to deactivate the visualization of all of this. And as I said before, this would be very ready now to, for example, be plugged in here and create these bricks. Okay, but we're not going to do that yet because we're going to put a pin on that one. Or, I mean, we can turn it off, why not? But it can already be there. Now, what is the next thing we need to do? We need to work on the central bricks. The central bricks are going to be very similar. It's just that the first one is going to be a little offset. So we're going to have to move the plane a little bit in that direction and then create a grid with a few less elements. So it's going to involve a little bit of numerical manipulation. So how are we going to do that? We're going to take the original plane, all right? And then we're going to create a new vector to move this plane and offset it here to the origin of the new collection of the central planes. So that is going to be a distance that is going to be half a brick in that direction and it's going to be a full brick in the vertical direction. So let's do that. So I'm going to go here, okay? and I'm going to move this plane. I'm going to take this plane and I'm going to move it, okay? And then how much am I going to move it? I'm going to move it by a vector that I'm going to create, that I'm going to say, I'm going to create a vector from x, y, z coordinates. The x coordinate is going to be half the distance of a brick. So I'm going to copy this expression and I'm going to say half the width of a brick. That's going to be the x. And then in y, sorry, not in z, is going to be a full height of the brick. Okay, so can you see how this brick is now like right there in the middle? Correct. So that is going to be the initial plane. And then at this point, I think the rules for making this and these planes are going to be fairly similar to this one. So what I'm going to do is I'm going to want to move this plane. I'm going to move the original plane. I will want to move it in the x direction by a series of vectors that have by a series of vectors that are like this, that are by a series of vectors that are apart a distance of the width of the brick, and there are apart the distance of the brick. So I'm going to create a new series, and which is going to start at 0, and is going to be the step size, which is going to be the width of the brick. All right, and number of values is going to be the number of bricks in the x direction. But that's actually not true, because you see, if I do that, then I get one extra brick on the other side. So what I actually need to do is I need to create an expression here, which is going to be, I'm going to, look at what I'm going to do. I'm going to press Shift and Control to detach this thing, this cable, and plug it into the other place. All right, and then here I'm going to say, whatever you give me, -1. And then I'm going to plug that in here, and now I have this many elements -1. And oops, actually, I think I connected too many things. So, okay, so let me do this. All right, now we got it. And then you can see how now I have 5 planes, each of 4 planes. So I have one less plane than in the previous row, right? And now what I need to do is I need to take all this row of planes and move it up in the z direction. So for that, I'm actually going to copy this as well. All right, and I'm going to say, I'm going to take all of this and then I'm going to move all these planes in z by a value that is 2 times the height of the brick and half the other direction, just like I did before. All right, so if I do that, then I'm going to get these planes, and if I turn this on and I plug the planes in here, you can also see that I'm very close. Let me do a frontal view. I'm very close to that. However, there's a tiny detail that is not going to work. Let's say right now we have 6 vertical rows of bricks. If I now switch to 5, you can see that it doesn't switch to 5. And if I switch to 4, it all of a sudden removes 2 rows. So, and if I switch to 7, I get 8 instead, and 8 stays as well, and 9 gives me 10 rows. So there is some kind of problem with me having odd number of vertical rows. And that is because when I have an odd number, it turns out that for the base bricks, so the blue ones, I should have half the amount of rows rounded up. So when I have 7 rows, I should have 4 of these base rows. But when I have 7 rows, I should have, for the central ones, I should have half this number rounded down. So that's going to be 3. And for some reason, this is not happening because here, when I am doing the amount of rows that I need to copy these planes up, so here, when I have these planes and I say, how many times do I need to copy them up? I'm using this expression here, and the amount of elements is being rounded up to 4 here in this series, because when I say how many numbers do I need? I need half x, x being the value of 7, now the number of rows. So here the value is 3.5, which is correct, technically correct. But you see that inside of series, it is automatically rounded up. Whereas what I need is this number to be rounded down. So that's why I'm going to be able to use the expression editor, which is wonderful, to find an expression that is going to be called the floor. And the floor is a function that takes whatever number and it rounds it to the largest integer that is less than the specified number. Or, in other words, it rounds the number down. So what I'm going to do is I'm going to say I want to calculate the floor of whatever this is. And this is already going to give me here the number 3, which doesn't get weirdly rounded anyway. And now I get exactly the 7 rows that I wanted. And if I now play with this, you can see that now 8, 9, 10, 11, 12, or less or more. All right? And I'm going to make this a little larger as well. Or not. I'm just going to, I'm just going to make this a little smaller because it's easier to control like that. Okay? Wonderful. So we have 2 of the groups. Now let's go off to the 3rd group. Well, in a way, this is going to be perhaps even easier, if you will, because at the end of the day, the only thing that we need to do is first calculate where this plane is, and then calculate what the distance to this other one is, so that we create 2 planes, and then we multiply that in the y direction using the exact same algorithm that we have used for this central row. So it's just basically the only difficulty here is calculating how far away these 2 planes are, and that is going to be like a simple numerical rule, which depends on how many bricks we have in the center plus half the size, etc., etc. So let's see where do we do that. So the first thing that we're going to do is we're going to take the first thing we're going to do is we're going to keep things tidy here. So I'm going to call this central brick planes, and I'm going to plug that in. I'm going to disconnect everything here. I'm going to disconnect this. I'm going to plug this in here, and then I'm going to turn it off so that we don't have the visual clutter. So first thing is going to be moving this plane to a position that is going to be here, that is going to be here. And this is going to be in the C direction, is going to be a full height of the brick. And in the X direction is going to be a quarter of a brick, I believe, right? Let's see if that is true. So I'm going to, first of all, I'm going to group all of this here so that it's clean and tidy. And then I'm going to take this X, Y plane, I'm going to move it all the way down here. And then what I'm going to do is I'm going to calculate myself a new X, Y, Z vector. And the X coordinate is going to be a quarter of the width. So I believe this one is taking the width. Yes, it is. So this is going to be 0.25. And again, this is the beauty of using expressions. They're super easy to edit. And then the C is going to be basically the height of the brick. So the height of the brick is going to be the C. And I forgot that this has to be negative. So this is going to be negative, and it looks like that brick is kind of halfway there. So let me turn on the bricks, and then let me turn on. Okay, so you see that this brick is already halfway there. So in order to make things a little easier for me, I am going to create, these are the full bricks, and this is going to be, I'm going to copy and paste all of this, and I'm going to create another one that is going to be half bricks. And half bricks is going to be basically the width is going to be divided by 4, and then it's going to be 2 and 2. And then as I do that, I'm going to plug that one in here, and you can see that I now have my brick. That is, and I see that there's like a little bit of like I will need to do a better job with the margin. So I will need to say 2 times the margin. Is that what I need to do? Yes, but then the margin is a little bigger here, so I will need to actually work with the margin a little bit to improve it. This is not, no, actually this is correct, right? Yes, so yes, you're right. So this is correct. So I needed to double the margin to align this here. So, okay, so I have that there. That is working, and then the only thing that I need to do now, that was just for the sake of prototyping, all right? So, but I need to take, I'm going to turn off, should I turn off the other planes? No, I'm just going to keep them there. So I have this plane, and now what I need to do is I need to calculate how far away do I need to move it in the x direction. So that's going to be a series. So I'm going to move this, and I'm going to move this. I'm going to move it in the x direction, and I'm going to move it with a series that is going to be, it's going to have 2 elements. So I'm going to just hard code this. I'm going to have 2 elements. So that's going to be the number 2 here. And then the step size between them is going to be some number. Apologies, my microphone just died. So where was I? I was saying that in order to take this, in order to take this plane and move it all the way here, I need to create a series of 2 numbers that start at 0, with the amount of numbers in the list is going to be a hard-coded 2, and then the distance that we're going to have these 2 planes apart is going to be something along these lines. So if you see, we need to calculate the distance from this point here to this point here. And if you notice, that distance is going to be basically all this distance here, which is the amount of bricks in the x direction minus 1 times the width of the brick. And then to that, I actually need to add half a brick, because you see, I have a quarter of a brick here and a quarter of a brick here. So that makes a half of the brick. And therefore, if I have 6 bricks here, basically the distance between these 2 points and these 2 points is 5.5 bricks. So this is going to be very easy to encode in an expression by just saying, let me create an expression that is going to be this is going to be the width of the brick, and this is going to be the number in the horizontal direction. So I'm going to plug that in here, number in the horizontal direction, width of the brick, and then what I want to do is I want to say I need to say that the width of the brick times how many bricks are in the horizontal direction minus half a brick. And I'm going to do that. I'm going to move this all the way down here, and I'm going to plug that in there. And if I now take this here, is that looking good? I think that's looking pretty good, isn't it? Choo-hoo! All right, so I think with this, then it should be just as easy as literally copying this one, which is the exact same one we use for the other rows, and then just plugging it in here, and then now plugging this in here, and we can see how we have now the perfect wall of bricks. And is this parametric enough? Let's see. I'm going to extend this 4, 5, 6, 7. This is looking pretty good to me. Okay, and then 6, 7, 8, blah, blah, blah. It looks pretty good to me, right? So, yoo-hoo! I think we have a parametric wall of bricks, which gives me a lot of OCD internal pleasure. Okay, so I'm going to just make sure that this is everything a little more clean and ordered. So this is going to be the edge brick planes. I'm going to plug those in here. I'm going to plug those in here. And if I turn everything off now, for example, and I make sure that these are off, and these are off, and this plane here is also going to be off, and this point is going to be off. And because I have this point, I can now move the whole brick. I can move it whatever I want. All right, wonderful. So this was a little tedious and it looks a little bit of an spaghetti, but at the end of the day, it was a lot of very simple numerical relations with each other, which at the end of the day is a lot of what we do in parametric modeling. It's just simple numerical relations between geometry. Wonderful. So with this, I think we are ready to now start tackling the problem of I'm going to say it. We're ready to start tackling the problem of oh my God, the problem of the explosion of the bricks. Sorry, I'm a little thick today. So let's take a look at the explosion of the bricks. All right, for the explosion, it's actually going to be fairly easy in a way. It's just that we're going to need to conceptualize a few things here. So one thing that we're going to do is, if we look at the wall in section, we will imagine that there is some kind of exploding artifact next to the wall, and then that the effect of the explosion of this artifact is going to affect the position, and eventually at the end of the exercise, also the rotation in 3D space is going to affect the position of these bricks. And as we already know, like for us, a brick, or for us, an exploding artifact, at the end of the day, we're going to abstract everything to what we're interested in, which is, for example, the center points that define those two agents. And if the rule that we want to incorporate here, the spirit that we want, is that of an explosion, then something that happens very often with explosions is that things that are very close to the exploding artifact are the ones that get the most damage or the most energy, and things that are farther away get the least energy from the explosion. So it turns out that if we have these bricks, we will probably want something along the lines of the bricks that are lower, closer to the exploding artifact, to move the fastest away, and then the ones that are the farther away to just move a tiny bit, right? So it turns out that we can find a pretty simple rule to do this, which is, because we can calculate the distance of the center of the exploding of the bomb to each one of the bricks, and we can do an inverse relation, and the shorter the distance, the bigger the affection that explosion has on the brick. If you remember, far, far away back in this series, when we did the exercise of attraction repulsion, we did it in a way where we affected the size of certain elements based on that distance. So this exercise is technically an attraction repulsion exercise, where we're just going to move the center of those bricks a distance that is inversely proportional to how far away they are from the brick, from the bomb. And then once we have those points, what we will do is we will generate those bricks on those positions. So this is going to be a piece of cake. Let's see how can we implement this. Before we do anything, I'm going to do something that I typically don't like doing, but because we have 3 families of planes, all the way, things are going to get a little confusing very soon. So what I'm going to do is I'm going to actually take all these planes and merge them here together and flatten them. So I'm going to right click and flatten them for the sake of having a full list of the big planes. And at the same time, I'm also going to create a very similar version for the other planes, so that it's a bit easier for me to work than with 3 families of this. And remember, I'm going to be working with planes. I'm going to leave the boxes to the very, very end just for pure visualization. So what are we going to do now? So what I'm going to do is I'm going to place just some kind of point here, all right, that I'm going to bring into Grasshopper. So I'm going to right click here and point, and I'm going to bring this in here, and this is going to be the center of the bomb. And then what I would like to do now, for example, is to calculate a vector that goes from this point to every single point of the big family of big bricks. So that's going to be 1. And then a similar one to the smaller bricks. I can visualize that if I say display vector, and then I can visualize these vectors on this point, and I can visualize those. You see? This component also gives me the length of each one of those, vectors. So if instead of visualizing those vectors from the center, I visualize them from their actual center, you can see that right now, if I were to use those vectors to move the planes, we would have the inverse rules. The ones that are farther away are moving a lot. The ones that are close are moving not so much. So what we need to do is we need to take those lengths and find an inverse rule. That is going to be an expression of the kind, the length, and what I want here is 1 divided by the length, which was the input x. And now, if I take these vectors and I force them with the amplitude command to have a length that is inverse, you can see that the vectors now have changed to something like this. You see that the vectors that are closer to the bomb are much stronger, and the ones that are farther away are weaker. You see this? So if I were to now take these vectors and move the planes with these vectors, you could see that the planes have now been modified by these vectors, and that if I plug that in here, you can see that now you can see how the explosion starts to play out here on the wall. You see? So now we are starting to get the desired effect. Now, this, however, is just an static way of modeling the bricks. But you have seen in the previous exercise where we did the grass that was blowing with the wind, you saw that we could use the concept of time as just a number that increases sequentially. We could use the concept of time to create animations that convey meaning. So for example, if I create, for example, I'm going to create I'm going to create a slider that I'm going to call time here. And that is going to start at 0 and it's going to have, I don't know, 3 decimals, and it's going to start at 0 here. And I say, if I multiply this value, if I multiply the inverse value, and if I multiply by the time, then whenever the time increases, the length of the vector is also going to increase, right? And therefore, if I use that rule, then what I can do is I can create vectors. That grow over time like this. Can you see? I can use vectors that grow over time like this. So if that's what I'm interested in, then I can use those vectors to represent the explosions. And therefore, you can see how now we have the wall, and then as soon as we don't, boo, the wall is kind of exploding like, and you see how it kind of still kept the, you see, yeah, which is kind of, I like this a lot. Oh, come on, how cool is this, right? And if I move this point, for example, and if I increase the size of the wall, right? So I'm going to get a much nicer effect here. Where is it? Where is this time? Can you see this? Bam. Quite cool, huh? Interesting, right? Alrighty. So that's that. And remember that we need to do the same thing for these other, for also the tiny bricks on the sides. So I'm going to copy and paste this, and the lengths are going to be these ones, the vectors are going to be these ones. We need to move these planes by these vectors, and we need to plug that in here. And now the tiny bricks on the sides are also going to explode according to this rule. Whoa, this brick is coming! Oh! We got in the way. Okay. All right. Okay, so we're very close. So now the bricks now explode with a rule of attraction repulsion, literally. And then I think the last thing that I would like to do is I would like to implement a rule where the bricks, because the bricks right now they just move as if they were ex- extremely linear, but that's not how it would work in reality. In reality, they would start rotating in some kind of crazy way, right? So I think I would like to implement some kind of random rotation in this explosion to give it a much more interesting feeling. So shall we do that? So in a nutshell, what we want to do now is imagining that we have the center for each one of the bricks representing where the brick is going to be located. What we want to do is we want to affect that plane so that not only it is moving in 3D space by the push of the bomb, but it's also, as it moves, it is increasingly rotating more and more. So if you see the brick, I can't really draw this, but this brick, like every time it moves, it would rotate a little and a little and a little and a little and a little. And the key here is that where is that rotating around? So for the trajectory, for the push from the bomb, it was kind of clearer because there was a good relation between where the bomb is and the direction that the brick should explode because of the energy explosion kind of situation. But for the rotation, it's actually not that clear. And if you see videos of things exploding in the real world, when they explode, they basically take some kind of weird spin in 3 dimensions. So that weird spin is what we are going here to model as a random vector. So for each one of the planes, we're going to create one random vector that is going to have 3 random coordinates, random x, random y, and random z. And then as we move, what we're going to do is that we're going to start rotating that plane around that random vector for an increasingly large rotational angle. At the beginning, it's going to be 0, but then as we keep going, it's going to be more and more and more. So, and how is that going to be? It's going to be some value that is also probably going to be random, and it's going to be multiplied by the time, so that the more the time passes, the more rotations we do. Okay, so I think the bottom line is going to be that the only thing we need to do is we need to model 3xyz random. We need to model a vector with 3 random coordinates, and then we need to model an initial spin velocity. Okay, that is also going to be random for each vector. And then we will use that velocity to multiply the rotation of the angle around that vector. Let's see how to do that in Grasshopper. And let's do one thing at a time, okay? Okay, let's focus first on the large bricks, all right? And we can see how here we have one component that contains 189 planes, which are the center of each one of the large brick planes. So what we need to do now is we need to generate 189 random x coordinate, 189 random y coordinates, and random z coordinates. So what we need to do is we need to double click here, look for a random component. The domain of the random numerical domain is going to be 0 to 1. I would like it to be in each direction, in all directions in x and y. So I would like to go from -1 to 1. And it turns out that domains can be written in a panel, just textual like that. So I can just plug that in, and you can see that my domain is -1 to 1. And because this is not, I won't need to really change this anyway, it doesn't really matter. The number of random values is going to be, in this case, 189. How do I know that? Well, I could find out the numerical relation of blah, 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 how many of these have plus this many minus the number of rows, whatever. But that's going to be a little too complicated, I think, because I have all the elements already on one single list. So you can see panel. I have all the elements in one single list. It's actually going to be much easier to just say, can you tell me the list length of this guy? And then this tells me that there's 189 elements on this list. And therefore, I can just plug that in there and boom, I have the 189 random values. And for the seed, I'm going to choose whatever, a slider that is going to start at whichever number. Okay, so these are going to be random x coordinates. Now for the y coordinates, I'm going to do something very similar. Okay, it's just that I'm going to plug in here the same, and I'm going to plug in here the same to avoid a little bit of redundancy. And here I'm going to add an expression that is going to be whatever the seed you gave me before. So I'm going to do +1, for example, or it could be 2 times that seed. It doesn't really matter. Okay, and we saw why this was important in the previous exercises when we were doing randomness. And for the third one, for the third list of z components, I'm going to do the same, but I'm going to add here the number 2. So I'm going to use this to create x, y, z vectors. All right. And just so that we can visualize this, I'm going to display these vectors, and the anchor is going to be the center of these planes. And you can see how I am getting, for each one of these vectors, each one of the planes, I'm getting a random vector with some random orientation in 3-dimensional space. Okay? Which is kind of what I want it to be. Right? Wonderful. So now, let's say that I take all of this, and what I do is I take each one of these planes, before moving it or anything, let's say that I take each one of these planes and that I rotate it by one of these, that I rotated a particular amount control around these vectors. So the way I'm going to do that is I'm going to go to transforms, I'm going to go to Euclidean, and I think I'm going to use rotate 3D, okay? Which gives me the option to rotate a particular geometry around, with a particular angle, around a center and around an axis of rotation. So, what is the geometry that I want to rotate? I want to rotate the plane. What is the angle? For the time being, I'm just going to drop here a slider. We will improve this in a second. So that's going to be whatever. And then the center is going to be this. If I deconstruct the plane, it's going to be the origin. And then the vector that I want to use for the axis of rotation is going to be those vectors that I just calculated right now. So I'm going to turn off all of this, and I'm going to turn all of this and all of this, and you can see that I have these planes here. So now let's see what is going to happen as soon as I start rotating this. So as soon as I start rotating, can you see how each one of the planes starts breaking out in a strange way? What? So let me use these planes to draw the boxes. So if I draw those boxes right now and I start rotating them, can you see how each one of the boxes starts now getting a weird spin, you know? And do, oops, yeah, and they all, oops, and they all rotate. When they all rotate when they all rotate 2 times pi, they all align. That is actually not a good thing. Okay, but you see how this is starting to look like a random explosion. Okay, so that's great. And so that's one thing. All right, and what is the next thing? The next thing is we're going to link that rotation to time. So for example, instead of a number, we can just use time. And now check this out. This is going to be seriously cool. As soon as I start increasing time, not only are the bricks going to move, but they're also going to start rotating in 3D. So check this out. What? What? Joe! All right, Joe, nice. That is very cool. Okay. All right, sounds great. It looks like we're almost there. It's just that there's a couple of things that I don't like. First, just like with the distance, the fact that all the bricks start rotating with the same amount of intensity doesn't feel natural to me. It feels like the ones that are farther away should start rotating less strong than the other ones. So maybe I need to factor the rotation by the distance. That's one thing. The other thing is that because they all have the exact same rotation, when the rotation is 6.28, which is 2 pi, you see how they all kind of align again? All right? That is not good because it's also pretty unnatural. It looks like there's a period of frequency at which all the planes align again. So that doesn't feel very natural. But I think as soon as I factor in the distance, that is going to improve everything. So if instead of multiplying by straight by the distance, what I do is I multiply by the factored. If I multiply by the factored distance, I think that is going to fix things here. So so check this out. So now I'm going to explode this, and you can see how these bricks start like rotating much stronger than these ones here. And they start like blowing out like boo. And now there is, if I do 6.8, 28, there's no weird interval. Yay! All right. Okay, so I think that is going to be the construct plane, and then I'm going to rotate all of that here, and then I'm going to add this to the group, and then I probably just want to use this to draw. So that's one thing. And then I think for the other ones, for the tiny bricks, I'm just going to copy this whole thing here. I'm going to now start substituting. This one needs to go here. This one needs to go here. This one, oopsies, this one needs to go here. This one needs to go here. And now this one needs to go here as well. And I believe that we should be fine now with the tiny bricks on the sides, right? Yeah. Woohoo! Yay! How cool is this? Huh? Let me run it from my side screen, and so that we can see like the large explosion. And then 3, 2, 1. I wonder, can we do this with a rendered view? Rendered view is not so good, right? Yeah, and it's kind of cutting down the bricks as well. Oh well, but it's cool. Okay, how about you give me 1 second? I try to render an animation and I show you the video of the render animation. Give me a second. Let me try that. Well, and I just finished doing this animation and I created all the frames and I turned them into an MP4 and it's looking something like this. Choo! Alrighty. All right, that looks cool. I like it. Oh, so I forgot to mention the way I created this animation out of the frames is using a command line tool called FFmpg. If you want to know how to do that, I have a video in my previous video on how to animate a grasshopper slider. You can get a sense of like a really quick sense of how to do that. And I think with this, that is everything I wanted to do. So I thought this was a good exercise to practice a little bit of data manipulation, a little bit of like the generation of parametric geometry, but at the same time understanding how to use randomness in a controlled way to generate effects that are inspired by nature or by physics effects. Obviously, this wall is not physically accurate because I mean, as soon as these bricks start rotating, they start hitting each other and blah, blah, blah. And there's like, as we extend them, there's no gravity pulling them down, which could also be incorporated here. So, I mean, there's a lot of things that could be improved. So if you actually improve it, make sure to leave a comment here on the video or post a link to your work. We'll be happy to broadcast it on our networks. Make sure to go to our Discord channel and share your work on the channel Work Sharing. And we will have a wonderful community who will be happy, very happy to see it. So I think that was it. I am pretty happy with the result and I am ready to move on to either new lectures or new exercises. I'm not sure what I'm going to do next on the series. But in the meantime, thank you very much. If you like this video, maybe consider hitting I like, maybe subscribing to the channel and turning on notifications, etc., etc., etc. You know how these things go. Thank you very much and see you on the next videos. Bye.